Okay, so we've spent 5 minutes or so looking at these 4 problems, trying to figure out what it is that is going to match the situation to its equation. So the understanding of situation to equation means that you have to understand what is changing every certain of something and where did you start from. So that's all that your y-intercept is where you began, where you're beginning, and then how it's progressing or how it's changing per a certain amount of time or situation, okay? So, what did y'all get for Pedro? Pedro's walking 6 miles from home. No, sorry, he is 6 miles from home, and he rides his bike at a rate of 10 miles per hour towards his home. Write an equation that describes the relationship between the time he rides his bike, x in hours, and the distance he is from home in y miles. So, what did y'all pick? Who agrees with Cooper? Who had something different? So he said y equals 6 minus 10x. What did you have, Adeline? 10 plus 6?
Y equals 6 plus
6 plus 10x, okay. Anybody have anything else other than that? So right now we have this option and this option. Anything different? What you got, Jordan? 6 plus 10x. Okay, so that's where we are. 6 plus and 6 minus 10x. Okay? Anybody else? Okay, so let's look at it. Pedro is how far from home? 6 miles from home, right? And he rides his bike at a rate of 10 miles per hour towards his home. So, let's think about this. If this is Pedro's house, and he is 6 miles away, he's starting at a what? A positive 6 miles away. He's 6 miles away from his house. So here's Pedro over here. He's got his fancy little bike, his Schwinn bicycle. Okay, and he's got to ride his little bicycle back home. So he's going which direction? Just think about it. If you're going back, are you going positive or negative? You're going negative. So we're going back at what? 10 what? 10 miles per hour. So now at this moment, is it going to be 6 plus 10x or 6 minus 10x? Who agrees 6 minus 10x? Good job. Okay, what did y'all get for the next one? Okay, who agrees with Cooper? He said y equals 10 minus 6x. Okay, anybody have anything different? At this moment, we're just explaining. Okay, so let's look at it. We're starting with what? 10 gallons. So, here's my bucket. It has 10 gallons of water in it. But there's a crack in my bucket. So if there's a crack in my bucket and it says that the water is leaking through that crack at a rate of what? 6 gallons a day. So are we gaining something or are we losing something? We're losing something. So if we started at what? 10. We're starting at 10 and we're losing something at what? A rate of 6 gallons a day. So, minus 6x. Are y'all okay? Yes? No? Okay. Ava, she's walking from her house to the store. So, here is her house. Here is the store. She, at a brisk pace of 6 feet per second. How fast is she going? 6 per second. That's going to tell me it's going to be 6x. 6 per something. But then it says she has already walked 10 feet from her home. Write an equation that describes the relationship between the time Ava spends walking in seconds and the distance she walks in feet. So, my question is, what are we doing? How far away from home is she? She's already what? So are we starting with a positive or a negative? Positive. She's starting with 10 feet. And she's moving at a what? A rate of? Towards the store. Is it positive or negative? Positive. Are we okay? The last one. The cost to ice skate is $6 for the skate rental and $10 for each hour spent ice skating. So obviously, one, you could do it by like, what's the word I'm losing? That word. Elimination. There you go. By elimination, you could figure out what the answer is going to be. But let's look at it mathematically. The cost to ice skate is $6 for the skate rental. That means that before she even starts skating, she has to pay how much? $6. And $10 for each hour spent ice skating. So that means it's going to be $10 per hour. So y equals 6 plus 10x. So how did you match each situation with the equation that represented it? What did y'all do? Huh? How did you match them? What was your thinking process whenever you were doing it? Okay, so Joelle's saying the per something had something to do with it, right? Yeah, the per is your x, right? Because it's an hour or a mile or a gallon, it's counting something, yes? So where did the rest of the information come from? How did you know if it was going to be positive or negative? The problem is going to give you information, right? It's going to tell you how far away something is, or how something, the distance from something, or if you're going to start somewhere. Does that make sense? Wow. Great job, guys. Okay, let's look at number 2. Lily already has some money saved, and she adds the same amount of money to her savings each week from her job at the taco truck. She making that money. Okay, here we go. The table shows time and weeks since Lily started her job and Lily's savings in dollars. Our first question is there a proportional relationship between Lily's savings and time? And explain your thinking. So, I'm going to give you 2 minutes to do A through D. A through D. I just want you to work through it. A through D, read through it, 2 minutes. And then we are going to do a think, pair, share. Think, pair, share. So, 2 minutes starting now. Go. What that means, but okay, here we go. So, they want to know, is there a proportional relationship between her savings and time? How do you find out a proportional relationship? If it's constant. If it's changing at the same rate every week. Is it changing at the same rate every week?
Yes.
Who agrees? How much is it changing per week? Okay, so everybody agrees that we're changing at 200 a week, but is it a proportional relationship? Do we have it, is every week the same? So like, here's 540 divided by 2. What does that give us? 270. Okay, but what's 940 divided by 4? Huh? 235. Is it changing at the same rate each time? No, it's not proportional. I'm going to explain. So if it's not proportional, that means that it's not starting at the what? Origin. It's not starting at the origin. That means that it's going to have a what? A y-intercept. That means that it's going to have a y-intercept. It's going to cross the y-axis at some point. So we're going to find the slope of the line that represents our linear equation. So what do you notice about the time listed in the chart? What do you notice about the time? It's what? It's going by 2, so it's every 2 weeks. Yes? So we're growing by 2s? So when the time increases by 2, how much does the dollars increase? 400. So every 2 weeks, the money increases by $400. So how do we explain that? What's our rate going to be? $200 per week. Okay, so what's an equation that we can write saying that her savings is Y, how much is in her savings, to the time in weeks that have passed? How can we write the equation? Who agrees with Cooper? Say it louder. He's saying Y equals 200x. Who agrees with him right now? The amount in her savings is going to equal 200 times the amount of weeks. But there's a problem. What's the problem? Okay, so we're looking at saying that every week, every 2 weeks, it's going to increase by $200. So, does it? 540, the next week's 3 weeks, then 4 weeks. So it went up 400 each time. Do we agree? Okay, so the goal is to see now, where are we? Well, we got to figure out what our y-intercept is. But do we know what our y-intercept is? No, we just know that her slope means that she's making $200 to her savings each week. How did you find the slope? Yeah, we chose 2 points on our graph. So you could have chosen 4, 940 and 2, 540, and that could have given you the slope, y2 minus y1 over x2 minus x1. That gives you the slope of your line. We're good with that. But then let's go over here to the next side and figure out what the y-intercept is. Somebody read me the first sentence. No. The first sentence of the original problem. Right, say it again, Adeline, bigger. Lily already has some money saved. That means that in her bank account, she already has some money, right? Okay, so Lily started with something. We need to figure out how much she started with. How do we figure that out? Okay, so he's saying she already had 540, so subtract 400 from the 540 because you make 400 per week? 200 weeks. 2 weeks. Now it's 2 weeks. Okay, so we need to subtract the 400 from 540, which would give us, how much? 140. That is a good idea. So we're going to go, just write down what he said. 140. That's where we're starting. Mathematically, this is how this works. So if y equals 200 times x plus b, and we have no idea what b is, what other information could we use to solve this? What do we have? We have the graph. We have the coordinate points, right? So don't we have an x value and a y value? Okay, somebody give me an x and y coordinate. Huh? 2, 540. So we can take this information and put it in this equation, and it will give us the value of b, which will be 140. Watch. So what's the y value? 540. What is my x value? Huh? It's what? Times 2. Equals, plus b. Ready? What's 200 times 2? 400. Now let's solve for b. What do we need to do? Subtract 400. So 140 equals our b, which is our y-intercept. There are multiple ways to do the same problem. So explain what the y-intercept means in this context. What does it mean in a sentence? The y-intercept of 140 means what? Lily started Yep, with $140 before she started saving money. Okay, how many weeks does it take for Lily to have $4,940 in savings? How can we solve this problem? Oh, what's an easier way to do it? Well, what's the Y mean in the problem? How much money she has, right? So, if Y equals 200 times X plus 140, and we already have the Y, 4,940, can't we just solve for X? Is that a possibility? Okay, so real quick, what's 4,940 minus 140? 4,800 equals 200x. What do we need to do next? Divide by 200. So x equals what? How much? 24. And what does this mean? 24 what? Who agrees with Cooper? 24 weeks. Okay, if Lily saves money at this rate for 52 weeks, what's the total amount that she's going to save? So, did y'all do this one yet? Yes? Okay, so Y equals 200 times 52 plus 140. What's 200 times 52? 1,000 what? 10,400. And then we added the 140, so the value of Y equals what now? Who? No. Yes. So what's our total? $10,540. That's enough to buy a car. It's going to have a lot of miles. Okay, ready? Let's look at the next problem. Y equals
5x plus 150.
Okay, 5x plus 150. And what does this represent? What's the 5 represent? Parking per what? Okay, and how much is the 150? The season pass. Okay, so how do we know how many times he gets to go? What do we need to do? It says he has a budget of 275. Where does that go in my equation? The Y. 275 equals 5 times X plus 150. So what is the value of my X? Well, you will have to subtract 150. That gives us what? 125 equals 5X. Divide by 5. X equals 25. So he gets to go where? So he can visit the water park 25 times. Okay, ready? 5 minutes. I want y'all to work on travel time. Sarah is traveling to her cousin's house at a constant rate. Her cousin's house is 459 miles away from Sarah. After traveling for 2 hours, Sarah is 323 miles away from her cousin's house. How many hours will it take Sarah to reach her cousin's home? Go. Okay, so real quick, how can we find the slope? Are we given any information? Any information? Okay, so she's traveling at a what rate? Constant rate. That means that our constant rate is going to be our what? Our slope. Our constant rate is our slope. Okay, and right now she's how far away? 450 miles away, right? Did she go anywhere yet? No, so she's starting at what? 0. So 0, 459. Then what? After what? 2 hours, she's where? 323 miles away. Can we use this information to find our slope? Yes. Okay, ready? So, 323 minus 459, and then we're going to have 2 minus 0. So what's 323 minus 459 on your calculator? Negative 136. And what's 2 minus 0? 2. And what's negative 136 divided by 2? Negative 68. So that means that she's going to be traveling at a rate of negative 6. Yeah, negative 68 per whatever, however much time it takes her, right? Okay, so we know that y equals negative 68x, and where did she start? 459. So how many hours will it take Sarah to reach her cousin's house? How do we figure that out? Did I write it wrong? I'm sorry. Well, what's going to determine when she meets at her cousin's house? How far away is she going to be? She's going to be what? 0 miles. Okay, so how do we solve this? So if she's going to be 0 miles away, where can we put the 0? The y. So if we put 0 here, how do we solve for x? X is going to be how long it takes, right? So what do we do next? Subtract what? 459. So now we have negative 459 equals negative 68 times x. Now what do? Divide by negative 68. So x equals, what did y'all get? Use a calculator. 6.75 what? Hours. So if you were to write that in a sentence, it would say it will take Sarah 6.75 hours to travel to her cousin's house. Period. Are we good? Why are we not good? We're not good in our understanding? Where are we? What's our questions? Yes, sir. Oh, you're good? Okay. So real quick, how can we describe the meaning of slope and a y-intercept of a line in problems with real-world context? The slope is the what? The rate at what? The rate it's doing what? Staying the same? No, it's the rate at what? Changing. So however much the rate is changing is going to be your what? Slope. And how do you figure out your y-intercept? It's going to be the what point? The starting point. Sometimes that could be 0. Could it be represented by other stuff though? Okay. So, for example, the amount of money Lily added to her savings each week was represented by the slope, but the amount that she already had was represented by the y-intercept. How does writing an equation to represent a situation help us answer questions about the situation? Once we have the what? Once we have the equation, what can we do? We can solve for any kind of variables, right? So, go ahead